solve problems that not too long ago would have seemed completely impossible to solve. For that reason, I am very excited to introduce our next speaker of the day. Ben Lamb is a serial entrepreneur passionate about emerging technology, science, space, and climate change. He is the CEO and co-founder of the world's only de-extinction company, Colossal. Prior to Colossal, Ben served as the founder and CEO to several companies, including Hypergiant, an enterprise AI software company. Interviewing Ben today is Jason Abruzzi's assistant managing editor of NBC News. Please join me in giving them both a warm welcome to the stage.
Welcome to De-extinction 101. This is InGen. And this is us, Colossal Biosciences. We're here to ease your worries on that scary de-extinction word and set the record straight.
That's kind of our specialty.
Join Mr. DNA and our team of scientists as we help separate the facts from the fiction. Let's go!
That's crazy. Ben, thank you for being here for what I'm hoping will be maybe the weirdest fireside.
Applications of AI using de-extinction?
Yeah, I mean, de-extinction, a word, I'm not even sure when that first came onto the scene. But we just saw a good teaser trailer.
Which we had all the rights for the trailer.
I'll check with our legal department.
Get some X nerds on it. So.
As an NBC Universal employee, that's good to hear. But when people hear de-extinction, I think obviously science fiction is the first thing that comes to mind, but we're now starting to see it in the real world. The first thing I need an update on is, how are the direwolves doing?
Good. We just gave our first pup date yesterday, and so we showed. I think we launched it with USA Today and a few others. I think NBC we sent it to as well, which I think they're covering, which is exciting. And we just integrated Khaleesi, our girl, into the pack with Romulus and Remus, and it went well. And so one of the things that, this isn't obviously AI related, but animal welfare is like key to everything that we do. And so the integration was a little bit nerve-wracking, right? It's like we're integrating a female wolf into a pack of two males that are older, and it went great. And they're all interacting great. They're on a 2,000-acre ecological preserve, and now they're completely integrated as a pack, which is awesome.
And I think they're a great real-world example of what you guys are doing, which is, a kind of science that even as of 10 to 20 years ago was, again, relegated to science fiction. How did you go from whatever the first idea was for doing this to having actual real living direwolves on a preserve?
Well, this is really all George Church's fault. So it was his idea in terms of like how we can use genetics and AI and computational biology to bring back species, as well as use those technologies for healthcare as well as conservation. And what's interesting is we had to build the entire system. So sometimes people are like, well, you guys raised a lot of money. Are you guys just an AI company? How are you guys looking at this? But fundamentally, we had to build the entire system. So we've got an AI core, we've got a computational biology core, we've got an ancient DNA core that goes out and procures samples. And then we have to use all these technologies to take those samples, compare them to the closest living relatives, and then engineer them into cell lines using genetic engineering. And then we have an animal husbandry team. And so there's all these different components that we had to go build for this systems model for de-extinction and conservation.
And you touched on this briefly, but let's get down to the nitty-gritty. How is AI being used in this process?
We couldn't do, to your point, we couldn't do our job without AI. So we're using AI in the ancient DNA reconstruction of the genome. So when we get genomes that are extremely broken, so for the Mammoth project, we have over 120 genomes ranging from 3,000 years old to 1.5 million years old. We then use AI to actually do all the comparative genomics, which is pretty interesting. So we have to try to understand what genes made a mammoth. Because for us, if you look at an animal and you look at an Asian elephant, which is 99.6% the same as a woolly mammoth, we want to identify the genes that really made a mammoth, right? And so we don't want to go in and just edit everything. We want to be really thoughtful about it. And so we're using AI in that process too. We're even using AI, this is kind of weird, not every single project we have unlimited genomes for. Like the Dodo project, we only have one genome.
The Dodo project being?
The Dodo.
We're bringing back the Dodo.
Bring back the Dodo, yeah. And so we only have one genome. And so we don't have 120 plus genomes. So it's hard from a comparative genomics perspective. And so this is interesting where we're looking at kind of converging AI and using kind of this multimodal approach where we're taking vision, artificial intelligence, and even natural language processing, and pulling into kind of this kind of system that we built using kind of this LLM framework from research, where we're pulling in all the data from all this bird beak morphology, and then we're also doing all the sequencing of about 100 different species of birds, and that are related, and some closely and some not closely related to the dodo. And then we actually did MRIs, and we did full 3D scans of every single bird in their skull that in that kind of group, so that we could build a pan genome. So then we could use our AI system to understand, okay, how do we isolate genes that we think would change the craniofacial morphology of the bird? So we're building these kind of like systems that kind of cross vision, cross deep learning, cross even LLMs, where we're pulling in data from all the scientific research to really understand, where we can even start our editing for that, because we only have one genome.
Well, I think you kind of just touched on where I want to go next, which was, why couldn't humans be doing that kind of thing? To ask it very simply,
Yeah.
What is challenging about what you're doing that AI is good at?
Yeah, well, I mean, it's just a ton of data, right? And so, and it's hard for us to parse it. So for example, when we did the comparative genomics for the direwolf, we had 2 direwolf genomes. One was 73,000 years old, one was 12,000 years old. We saw that, direwolves were white. We found out that they were white. We looked at it, we looked at the data, they're white. Game of Thrones got it correct. Lots of people on social media yelled at us because they saw a picture that someone painted of them as red. And they're like, no, we saw a picture that someone painted and they were red in 2015, right? I was like, well, they weren't alive in 2015. And so, but what we found, and this is where AI was really helpful to us, what we found is in the data, it's like, go make this genome, this edit in the genome to make them white, right? And here's the gene specifically that made them white. But then when we pulled in all this literature, we actually found in dogs and in other wolves, some of those same gene variants actually cause blindness and deafness. And that's not something that the computational analysis showed us in the data. And so pulling in all this extra data and having AI parse it, it kind of gave us this red flag of saying, hey, if you go make this change, there could be an animal welfare issue to it. And so we didn't use that data and said, okay, we're gonna have the same outcome, but we're gonna use this gene variant over here because it's safe. And that's something that, the data, us just looking at the raw data without leveraging AI to kind of look at all the ingestible data, we would have known.
No, you kind of just touched on where humans start entering the process and the decisions they have to make. What kind of work does your company do, and do you do, thinking about anything moral or ethical or societal ramifications of these technologies? Obviously, I think people hear them, including myself, and they start going, that's scary stuff. What else could it be used for beyond doing things like that?
It is crazy. And for us, as it relates to synthetic biology, we're working with the federal government, we're working with indigenous people groups, we're working with a lot of different collaborative groups around the world to actually think about how we build frameworks for leveraging synthetic biology. Being that AI is core to our business, we're not just purely an AI company, I wouldn't say that we're out there saying this is like ethical frameworks for AI, and there's a lot of people that are doing that. Thank God we're past the temper tantrum phase of AI where everyone's just sad and scared and weird, and now we're in the point where people are like, okay, now it's here, we're in the acceptance phase of grief, right? So like we're like actually working through it and implementing it, which is awesome. But for us, we have to think about kind of like what are the results of taking the insights from data from the AI systems in the data that we get to apply to whether it's animal welfare in the case of like the direwolves or in cases of human genome engineering. And so if you look at Colossal, we're making 75 plus edits at a time using kind of our system and our models and that actually help us design these guides of how we are delivering large payloads into cells. And other labs are doing too. So it's quite a big step function, right? And so when we think about that, and we think about then the application of those technologies to humans, and there's now companies wanting to do editing in embryos for humans. There are ramifications to the advancement of these technologies, and AI, and then eventually quantum, are just going to massively accelerate that. And so on one hand, you can say we want to cure disease states. On the other hand, it's like, okay, how much germline editing do we want to do in the gene pool that can be passed on to the next generation? And so those are like really hard, not just regulatory issues, but moral hazard issues. It's like, where do we draw the line? If we can eradicate a disease in a child, do we do it? Or do we say, if we can, increase intelligence, do we do it? So these are the things that I think that really synthetic biology, genome engineering, and AI and eventually quantum, like that kind of convergence is going to really change and make us really think about what it means to even be human.
And when you try to communicate to people outside of the company or even outside of AI, you had a funny post on Twitter recently about how you
I get a lot of feedback from my posts, so I make less posts these days.
Yeah, but it was a good post because it was saying like you get the same 10 questions over and over. You can train an LLM.
Oh, my LLM,
to answer them. I mean,
So you know what's interesting? I said that, and then someone made a woolly mammoth chatbot. I didn't make that. Like someone made a woolly mammoth chatbot. Like, okay, and then they made it. But yeah, I did make a joke saying that like we get asked that because it's interesting, right? It's like we'll talk about like conservation, like all the technologies we make are available for conservation. We're deploying technologies into conservation. We even raised a foundation with $50 million for conservation, and then people will be like, you guys should do stuff for conservation. It's like, well, there's a button on our website that says conservation. We have a foundation. We mention it every time we open our mouths. So I was like, maybe I'll just make an LLM and like we'll just take down all of our stuff and you can just talk to a bot.
Well, and I was going to say, how crucial is it to be communicating with the public right now about like how this technology works, the safeguards being put around them, the thought that is being put into it?
I think it's really important. And so one of the things that when I started the company with George, I thought we were going to spend a lot of time in the lab, maybe some like, dungeons and like sub-basements like the Smithsonian, and maybe some field work, but I never thought that we'd spend, half or more than half our time in the field, right? And so we spend a lot of time educating. We spend a lot of time with lawmakers. We spend a lot of time with government because the work that we're doing doesn't, it transcends borders. It transcends geopolitical frameworks that currently are existing, right? Like mammoths don't see borders. Dodos saw a little bit of border because they were an island, right? But some of these species don't. And so we have to think about that. And then we're also spending a lot of time with even indigenous people groups, right? And so we just announced our MOA project. And before we ever would work on the MOA project, we went and worked with the Naitahu Research Center and the Maori people because that's part of their Tonga and their sacred species.
I was going to say, what is the MOA project?
So the MOA is awesome. It is, I'd argue it's the closest thing. It's not genetic. I'm really careful about saying it is not genetically the closest thing to a dinosaur, but it is probably the closest thing that humans lived next to a dinosaur. It's a 12-foot flightless bird that didn't have wings, that was native to New Zealand, and it's awesome. It was really helpful to the vegetational overgrowth of canopies. The Maori people actually hunted it to extinction, about 600 years ago, and we actually have the DNA to bring it back. But even in that process, not only educating lawmakers and others in the field, and journalists and the public at large, we have to go work with the indigenous people groups to make sure they understand the application of the technologies, where the limits are, and also get their permission and buy-in. So we have to spend a lot of time, I'd say half of our time is spent on education and transparency, which I think is really important, even if I occasionally make jokes on Twitter.
The applications of AI, I think, is what is most interesting about what you guys are doing, right? A lot of people here, I think, know that AI is more than just a chat GPT or a bot. But talk to me about some of the applications you guys are starting to pursue on the bleeding edge. What are you excited about starting to really focus on?
So one of the things that we are just now testing, and it's working so far, but it's still the early days, is how can we create feedback loops so we make a lot of cell lines, right? We make a lot of different edits, and we're using different combinations of edits. And different edits, whether you're inserting a big piece of DNA or just knocking out a small piece or just changing one little rung on that, twisted ladder of DNA, we like different ones have different editing modalities, and different editing modalities have different efficiencies. And so we're combining all that in a pretty interesting way. But if we just do that randomly and one cell line works and one cell line doesn't, how do we know if what we're doing is the right way? And so feeding all this data into a feedback loop, because we're now creating enough data that we can actually train a system. So we're now actually a recommendation system that's actually saying, okay, for this type of edit, if you want to produce this type of result, you need to use these tools, which is really interesting. And where I think it's going, and this is where I'm hopeful, we hear quantum's 2 years away every 2 years, but I'm very excited about quantum and AI because I think that eventually we can do simulated wetware or lab work using AI and eventually robotics. And so if we can empower AI and quantum and AI into eventual robotics, and we're talking about, the Tesla robots, like the laundry stuff's cool, but ultimately, I think it'd be really interesting to say, how can we run simulated experiments all, in a system, and then say, okay, here's like the 80% probability if you make these edits, then have robots do that in there, so that then the scientists can just do an analysis of that final product, right? And so that's where it's going, and that's where we're spending a lot of time, at kind of the intersection of AI and robotics, and then simulation, and hopefully getting ready for quantum.
All right, well, if you brought up quantum a few times, then we're going to have to go there. Walk me through why quantum and AI is something to get excited about. What about quantum?
It's endless, the theory, right? And people are doing this. There's great companies out there doing this. But the application of being able to run so many simultaneous experiments in a true simulation, right? You hear about like the fact that we're in simulation. Some people believe that, some people don't. But ultimately, being able to simulate a lab environment and a wetware environment, and there's many examples of using quantum for communication and defense and others that are much more interesting probably than what we want to use it for. But the ability for us to, look at like what is the probabilistic success rate of these edits using the data that we already know is working, that we've been feeding back into our AI system, and then being able to simulate all these experiments at once, so that we can simulate all of these different gene combinations, pulling in the literature, right, so that we can look for issues like, the genes that could cause deafness or blindness from the direwolves, and if you implement them in today's wolves. Those are the things that I think are super interesting, because then you can essentially get that data and insight and report saying, okay, go try these 5 experiments, right? Versus us just being in the field of discovery. And I really think that empowers us to move from the world of scientific discovery to scientific engineering. Like right now, it used to be like 90% discovery, 10% engineering. I'd say it's more like 50-50 or 60-40 now. But I think in the future it's going to be like 95% engineering, because of these tools and technologies, and 5% discovery. Because the discovery is going to happen in the system.
That's well, and for lack of a better term, you just need more horsepower.
Yeah, we just need more horsepower, and we need concurrent horsepower.
And that's what quantum can offer.
Yeah, so it can offer a lot more other things like security to other people.
Sure, for you guys. In terms of, what else you got coming down the pipe? Is there anything else, any other animals that we can expect in the near future?
Yeah, we surprised the world with the woolly mice. We surprised in Chippendale doing quite well. Yeah. And then we surprised the world with the direwolves, and it was interesting feedback. It was great. And then we're very focused on our flagship species. There's nothing else to announce yet, but I think that we'll show progress before the end of the year. Not a Dodo, but we'll show progress on our avian genomics group before the end of the year, which we're pretty excited about. We've had a couple of cool breakthroughs there, and then but we're not going to be announcing any more species this year. Yeah. And well, only 2 this year.
Yeah. And in 10 years, where are you guys hoping to be? Like what does this company look like down the line?
Yeah, I think in 10 years, if everything goes right, we've brought back all of our flagship species. We've successfully worked with indigenous people groups, private landowners, and governments to put them back into their environments. We're testing the applications and the implications of how they're affecting the environment, hopefully in a positive way. And then I hope that the technologies that we've developed have expanded beyond just conservation, where they're not just being field tested, like with the northern white rhino and vaquita type projects, but actually being implemented across the board for everyone. So that would be where I hope we are in 10 years, and I think that we're currently on pace to do it.
And would you say that means the end of extinction? Like, is that even in the realm?
Yeah, I mean, look, it is more expensive, and it's a great question. It is way more expensive to bring back something and re-engineer and rebuild an extinct species for today than just preserve today, right? Like, I would hope that we would change, people's views, but we are in a world where 50% of biodiversity could be lost between now and 2050. That's not that far away. And so another implication that we're doing right now is the implementation of bio vaults. So we're working with several governments around the world to actually protect their species, take their samples, and not just put them in a fridge like some people are doing in biobanking, but actually go do full analysis on them, do all the ATAC on them, do all the different genome sequencing, build a population diversity map so that we say, okay, yeah, there may be 200 rhinos over here, but are they healthy? Are they inbreeding? Where are there going to be forecasted genetic bottlenecks? So that's a big initiative that we have and our foundation has to do that, so that it's almost like a Noah's Ark type mission because I do think, you know, it's going to take a long time to change. It's going to be much harder to change consumer behavior than to advance the technologies. And so, you know, I still think it's cheaper and better to save what we've got than what we. And that's weird coming from the guy who runs the De-extinction company, but I think it's much better to do that than what we do. But I think we need a safeguard, and we just don't have it, because we know that while modern conservation works, it's not working at the speed at which we're, you know, eradicating shit.
Absolutely. Ben, thank you so much. It was wonderful. I think we just exactly nailed time.
Oh, awesome.